What I loved about this meetup tonight, and I think thanks to Olivia for putting it all together. Thank you, Olivia. Is that? So what I love is that we've got 3 talks on basically the same sort of subject. We're talking about materializing stream data into Kafka for analytics, and 3 vastly different takes. We've had Roman's take on a very, very tightly coupled way of doing it with Kafka streams and with core Kafka. We've had Hugh and Peter's take on it, which is a decoupled way of doing it. And now you've got the outlier. Now you've got the slightly crazy one, so bear with me on this one, where we're not going to materialize the data at all. What we're going to do is we're going to materialize the instructions on how to create that materialization, and in a process known for the last sort of 30 years as indexing, and indexing in Kafka. So in this talk, we're going to talk a little bit about why Kafka needs more than produce and consume. This streaming API has been the cornerstone of Kafka ever since its inception, and it's been brilliant for a wide range of cases. But when you start moving into the analytical world, it starts falling short. And we're going to talk about what we can do in order to extend it and how it kind of fails at this point. I should really tell you what a point lookup is before I go any further. So a point lookup for me is where you have a set of coordinates that match down to either a single record or a very small set of records in a topic or table or anything like that. So it's given topic transactions that has a key with a transaction ID. I know that transaction ID, and that's what I want to pull out of it, right? Something very simple. Nice and easy. Databases have been doing it for years. Kafka is absolutely goddamn terrible at it. So we're going to talk about why that is and how we do it, and we're going to do a very light technical dive into how we've achieved this. And then I'm going to do a very, very short, because I'm running out of time fast, work demo. A couple of things we won't cover. This is not stream processing. Sorry, guys. I'm going to stay predominantly in the batch world today. And the reason for that is most point lookup cases are batch. You're doing this kind of thing as an investigatory task, usually because something's gone wrong. You want to pull out that record, figure out what's going wrong with it, and then throw it away. You don't really want to track it till the end of time after that. So it's not a streams processing case. It's an analytics case. And hopefully, by the end of this talk, I'll have convinced you that that's still relevant in Kafka. The second thing I'm not going to cover, because I can see from Roman's talk that he could run circles around me, is theories on effective indexing. I'm not a mathematician, and I'm going to stay away from it and focus really on how we apply simple indexing to Kafka rather than the best indexing strategies. So with that in mind, I like to take a quick poll of who I'm talking to first. Who's here is running Kafka in production? Hands up. That's not as many as I thought. That's quite, okay, fine. Keep them up. We need them up for this. All right, keep your hands up if your day-to-day job involves interacting with data in Kafka. I mean, actually looking at it, reading at it. I don't care what tool you use to read it, but day-to-day, that's part of it. That's more than I expected. That's pretty good. Keep them up. We don't know. All right. All right, next round. Keep them up if you're interacting with that data for analytical purposes. Hey, this is doing better than Kafka Summit. So I'm impressed with this one. And the final one that I'm guaranteed we won't get any for. Keep them up if that analytical thing is exploratory. You're looking through your Kafka data. Actually, you can win. You can actually win. Nice one, Hugh. Well done. So by exploratory, I mean you're poking around inside your Kafka data. You're not entirely sure what you're looking for. You've got a vague idea, but that's what you're doing, right? Hugh's the only one because he's poking around in order to make effective demos for imply, which is, let's face it, a pretty specialized use case. And my main question for that is, why is that? Why is it that we don't use Kafka? If I pick any one of you at random, maybe the guy with the stream-based t-shirt on. Let's pick him. He looks like a random guy that's just walked in off the street. Why don't you use Kafka for these kind of analytical cases and exploratory cases?
Because Kafka is not built for it.
Whoa, how the hell did I know that? Because that's not what Kafka's for. And to a certain extent, that's a perfectly valid argument. But I'd like to take you back for a very brief run through Kafka's history on the history of that's not what Kafka's for. Kafka started as a message bus for communicating between microservices, right? Really good at it. When a few years later we decided to start doing event processing, there's a whole bunch of people that said that's not what Kafka's for. Yeah, it's probably the primary use case for Kafka today. You go for take on Flink and Spark and go on to the observability world. There's a bunch of people that said, that's not what Kafka's for. You need an external system to do this, right? And finally, here we are arriving in 2024, and we're starting to use Kafka directly for complex analytics. And the most common question I still hear is, but that's not what Kafka's for. There's a couple of trends that go through that history, right? First, the role of Kafka is expanding and continues to expand it. I've spent 7 years of my life now working on Kafka, and my favorite thing about Kafka is it keeps changing, it keeps moving, and it keeps adopting new cases. It's really exciting, and I absolutely love it. And it's driven by a larger amount of data. I've not really seen anything transform in this way, except the last project I worked on, which was Apache Hadoop. Right? That moved and transformed, and again, that was driven by a larger amount of data. Just kept going and kept going. And as it goes, people go, wait, there's a really, really big store of really useful data. I should probably do something different with that. And don't stop, by the way. That's brilliant. Keep pushing people, keep doing that. That's what the project's for, and it's fantastic. But one little trend that I wanted to flag while we're here is that the adoption of new features is accelerating. If you look here, it took 6 years to get to effective event processing, another 4 to get to observability, and only 2. I give it another few Kafka summits, and we'll be delivering massive new features every week. So what that means, by the way, is that the balance is shifting. Kafka originally, purely transport, and that's the way our mindset works. That's what we thought about it. It gets data from A to B, right? And it has a small buffer. There's a small historical element in here. The most recent changes that we see are focused on Kafka as a fully fledged storage layer. If you think about the likes of Kit 405, I don't know, hands up who's heard of Kit 405? Hey, that's really good. I like that. Kit 405, for those that don't know, is the integration of Kafka's data layer with basically very, very cheap and cost-effective storage for cold data sets. So it allows you to push your old data in Kafka up into something like Amazon's S3 or Azure Blob Storage or something like that, somewhere where it's really, really cheap. That sounds complicated. What it really means is I need to change your thinking from what retention should I use to this topic to do I even need a retention on this topic, right? It should be, if you're, say, firing up a Confluent Cloud or something like that, and you're creating new topics here, they have a little tick box for unlimited retention. It's currently not default on, but it really should be. Right? You should have a business case for not clicking that button because you don't have a cost case anymore. That's it. It's now efficient and really, really cheap to store all of your company's data in Kafka. So that's great. We've got Kafka as a data lake. I'm going to start calling Kafka as a data lake now because that's what it is. But it's missing a few things. Anyone wanted to take an attempt at what the hardest thing to do in Kafka is today? Scale. I'd say that's the easiest thing to do in Kafka today. You go and find any one of a number of managed services and feed them more money. Still, as it was on the first day that I started working with Kafka, the hardest thing that I find to do with Kafka today is to find a single message in a topic. And anyone who's worked Confluent support, I know there's a couple of people in here, know that this is a very, very common case. This is something you need to do quite often. And I'm going to show you why this is hard via the medium of the console tools. Okay, none of you can see that at all, can you? Okay, we'll do it via description. This is the audio-only version of this. We'll have subtitles beneath. Okay. I'm going to show you via the console tools. Obviously, no one would ever do this, but it demonstrates the principles so well that I couldn't ignore it. So I want to go and find my specific message. I have a bunch of criteria. And the criteria, by the way, are value fields within the value of the message. They're not anything I can use technically like an offset. I mean, who really knows the offsets of their favorite messages? No? If you do, you really, really need a break from Kafka. Take a holiday or something. So the first thing you need to do is find out how those criteria can be mapped into the message structure. And for that, we've got schema registry. So for those that can't see, this is a curl on schema registry, and it's showing me that my transactions message has a field called payment term code, right? And therefore, now I know that I can map my payment term code criteria into a message. That's brilliant. The second step sucks. The second step's really painful. Now I have to fire up a console consumer using the dreaded -- from beginning command. and pipe that through to a grep. No one would ever do that, but it's actually very indicative of what a lot of the tools, particularly KSQL, damn you KSQL.
I do that every day.
There you go, does it every day. You're gonna like this talk. You pipe that through to a grep, you're gonna read every single message on that topic, and you're gonna go, does this one contain the payment code? Nope, drop it. Does this one? Nope, drop it. Does this one? Nope, drop it. And you're gonna go all the way from beginning to end until you get an answer or fall asleep. One of the two things is probably gonna happen. And then, and this demonstrates the importance of having a good way of describing our criteria, you're going to realize that you didn't put spaces in between the colon and your JSON fields, and actually you forgot, and actually it's brought back a completely different set of results that you didn't want. All right? So, agreed. There are some absolutely fantastic tools that can give you this capability, but typically they involve first moving the data downstream. Druid, by the way, is a really brilliant one. Use Druid, it's fantastic. There's going to be a lot of like Druid from here on in, so get used to that bit. And like Druid, you could, today, this is how this case is handled today. Like so what is your name?
Arthur.
Arthur. Like Arthur says, he does this every single day, so this is a case that needs solving. And it is solved today, but it's solved primarily by offloading data. Kafka Connect is probably the best data integration framework I've ever seen. And it's got a whole host of connectors that you can use to pass the data down into something that is much more palatable for our analytical purposes. So you could sync it into a Postgres or write it over into S3, and then you get the wonderful world of SQL. SQL is still here, by the way, because it is absolutely brilliant at what it does, to describe all your criteria and make sure you're pulling out the correct point lookup. This is what we do today. And it works. It works really well, and it's really powerful, so why on earth is this idiot standing up here trying to tell you not to do this? Well, there's a few reasons, but the ones I'm going to play with tonight is a nice little game I like to call consistency bingo. By doing any kind of offload, you've created two copies of the data. You have a view from your Kafka world, and you have a view from your downstream analytical world. And these must be kept consistent. Anyone who's ever worked with any kind of Confluent or Kafka, Kafka replication product, will understand that this can get incredibly painful. And I'll put a few up here. I reckon everybody's seen at least two, maybe even all six of these. If you have seen all six, stick your hand up later. But yeah, brilliant. So we got things like source topic deletion and recreation. Really simple, right? I create a topic, I produce a million messages to it, I delete that topic, I recreate the topic with the same name and produce a million messages to it. What should the downstream system have there? Is it the first million, the second million, or 2 million? The answer is not solved by technology. That's a business problem that you have to solve. So you can't just assume that your connector is going to handle that because you have to tell it. And second one, same sort of thing, but slightly more subtle. Kafka's transactional. You can start a transaction and it handles that transactions by writing sort of fake messages to the topic. As soon as you abort the transaction, it writes a marker that says to ignore these. That's fine. Now, what should the downstream system do with that? The default, by the way, is for the downstream system to see them all. And in a particularly annoying thing about Kafka, it gives you no indication that they were a part of a transaction at all. They just appear like regular messages. Third one, lag. Let's say I've got an hour retention on my topic and my downstream system's down for 2 hours. What have I done? I've lost data. All right. It's painful. Schema evolution's fairly self-explanatory. We're going to add move, munge fields. It has to be reflected in the downstream system. Governance is also fairly self-explanatory. We've got to do authentication and authorization. We're now doing it twice. Probably using different schemes, probably using different systems. And Leo at the back is holding up 3 times, and he's right. You've got to do it also for the transport layer that's moving it from one to the other. And then finally, the one I should have started with, resource usage. You got double. There we go. Have you got bingo? Hooray! Yeah, you got double the storage, double the resource usage, everything like that. So what can we do to solve this? Well, there's a lot of very great companies that handle all of this consistency and do it really, really well. Druid is one of them, implies one of them. Druid is a fantastic product that does handle all of these situations well. But we took a step back and had a thought about, like, for a lot of cases, it's a lot of different cases to Druid, I'm trying not to compete. Yeah, we're not competitors. We do different things. For a lot of cases, you don't actually need to offload the data at all. What if we could have just kept that data in Kafka and had a more effective way of finding the data we need than just reading from the beginning to the end? And the answer to that is indexes. Because if you have an index that says, in its simplest form, this chunk of topic doesn't contain this data, you can skip it. Okay? And less read equals speed. That's the rule of data systems since the bygone age. So Iceberg's the hot topic right now. One of the reasons Iceberg was created was because there was this read-based problem where you had to list thousands, maybe millions of files in order to find the ones that were relevant to your queries. Right? It was causing real big problems in Hadoop clusters and other storage mediums and things like that. They solved it by creating hierarchical indexes that for different types of queries and different types of problems narrow down that the file set that you need to solve it. Now, we in Kafka don't have files. Actually, we do, but we can't see them because they're hidden behind the APIs. But what we do have is offsets. What if we were just to treat a block of offsets of an arbitrary given size like it was a file in Iceberg? They're immutable in exactly the same way. We can just say, well, do we need that block? Do we not need that block? And we can drop it, do less read, and hence get speed. Obviously, I'm going to show you the example on the screen with the core use case for Kafka, which is storing pictures of cats. And we can see from this angle, we've got offset 0 to 100 contains only tabbies. And we've created our index that says that. Right? Offsets 100 to 200 contains only gingers. And offsets 200 to 300 contains tabbies with the odd tiger snapped in. By having that index, we now know that if we just want to select out the tigers, we don't need the first 200 offsets. We can skip over them, and we've already just made ourselves a 3x speed up by doing nothing else. Fantastic. And it doesn't have to be just for selection, doesn't have, or anything like that. What happens if we were to, you can really slice and dice these indexes in any way you want once you've decided on this structure of a block of offsets will be referred to by an index. We can add some extra information and say, look, there's 3 tabbies in the first one, 3 gingers in the second one, 2 tabbies and 1 tiger in the third one. Well, if we want to select tabbies, we don't even need to read any data right now. Right? We know that we can just consult the index and go, right, so from beginning to end, we've got 5 tabbies. Fantastic. Done. Lightning quick. No one yelling at me yet? I do like a good heckle. So, no? Someone at this point, I was hoping, was going to be yelling latency at me. No? No. Okay. Latency. The trouble is, creating indexes is expensive. Happens asynchronously in the background. So what we end up with is a situation that looks more like this, where we have a cold set, we'll call it. That's a really dodgy term to be using with Kit 405 around, but we have a cold set that's fully indexed and ready. And we have this head of the queue here that hasn't yet been indexed. Right? Could be a major problem for us. We're going to sacrifice latency for the sake of performance on the longer range of queries. Yeah, it kind of sucks. But the important thing to remember about this kind of indexing technology is it's acceleration technology. What we're doing, we're not storing the data itself here. No, there's no data. It's just metadata about the data itself that helps us increase performance. So when we encounter a scenario like 200 to 300 here, where we have no indexing information, it's really nice and easy. We just fall back and read it. We just don't get any acceleration out of it. We go, okay, no indexing. I don't know if I should read 200 to 300 or not, so I'm going to. And what that means is you get all the benefits of having your super low latency, really up-to-date Kafka system, but you're able to extend your queries into massive ranges in the past and pull out all of the data that you want. Demo time. I like to keep my demos really, really realistic and really close to my own experience. So this is a genuine thing that I experienced pre-streaming applied to streaming. Before I saw the light and moved out of corporate life and into the tech world, I started my career working for risk management systems in investment banks. And I used to get woken up at 3 o'clock in the morning an awful lot. And one time in the early 2010s was at about 3 a.m. to tell me that the exchange rate pairs for reporting wouldn't load. Exchange rates wouldn't load. This was pre-streaming, so these are files on batch jobs. Good old-fashioned days. It was great. We went investigating, and we eventually found out that the problem was the Zimbabwean dollar was devaluing so fast that the exchange rate was so large it wouldn't fit in our database column. This is a real thing. It happened. Google it. You can buy a $1 trillion Zimbabwean dollar note. It is possible. They tried to print money faster than it can devalue. It's brilliant. So what we're going to do is we're going to do that exact same case. We're going to imagine that phone call's gone off at 3 o'clock in the morning, but we're going to do it using our index Kafka topics. Like Druid, our stream-based technology also surfaces as a JDBC connection and integrates with all your favorite tools, in this case, Apache Superset. And I've got 2 topics here. One named transactions, which is a Firehose topic that contains all transactions for every store. I'm going to pretend I'm a retail partner. We provide shopping services and payment transfers. Can I make it bigger? Can I? That's a very good question. No. That any better? Not really, but you get the idea. Maybe. Oh. No. That's the best we're getting. So transactions is our Firehose topic. That's got every transaction for every shop in every currency pair, every kind of payment on it. And it's got, give me one sec. It's got 2.5 million messages on it. Should have? Yeah, roughly. 2.5 million messages. We then got our payment terms, and this is details about how to settle payments. So it's a reference, it's a, it's a set of reference data. So it's much smaller. We've only got 1,000 messages on that one, right? And what we're going to do is, I'm not going to bother describing them because I'm already way out of time, but you can imagine they have fields relating to transactions and fields relating to payment terms in them. It's not important for the demo, but if you wanted to, you could describe them and it would show all the fields and columns in them. So what I'm going to do, I've got my store ID that's having a problem. I know this is my store. All its transactions are failing. And so this is my needle criteria. And what I'm going to do is I'm going to pull the needle out of the haystack. So if I'm running like this, oh, I know what I've done wrong. There you go. Sometimes superset can be very clunky. And I know, so I'm pulling it up and it returns immediately. And it returns immediately. And the reason it's doing that is because this is a very small amount of data. If I was to take it away, it's only about 2,000 records that are relevant to my query. But 2,000 out of 2.5 million, that's about right if you had 2,000 stores or something like that. You know, we're in the right kind of ballpark for the kind of investigatory queries we want to be doing. And immediately I can see there's something wrong. Here, a lot of my queries are going through fine. A lot of my transactions are going through fine, but everything with the payment turncode ZWD has a USD amount of 0. And obviously a 0 amount transaction is not valid, so what on earth is going on? Well, I can see from here, as part of my investigation, that it's related to this ZWD. So, and just before we move on, look, Streambase is really cool, and we gave you this ability to turn acceleration off just so we can show how fast we are. So, you remember how that was instant? If I was to run it without the acceleration, and it runs for a much, much longer time. Okay, we won't do any more sales jobs than that, I promise, that's it. It's still running. Come on, there's not that much data. So that was about 11 seconds without acceleration and about 1/3 of a second with acceleration. You get the idea. We can do 10x, 20x, 30x, 100x. Depending on the data set and how you index it, you can go really freaking fast. And I better remember to turn it on, otherwise this demo is going to take a lot longer. So what we're going to do next, as I scroll across to try and make it fit on the screen, is we're going to join the transactions with the payment terms. Like any other kind of system, we have a full ANSI SQL language. It works great because that's the best way to describe your filter criteria. So if I pull that out, this is all coming directly from Kafka, by the way. None of this has been materialized into an intermediate store or anything like that. And just in case you don't believe me, Here are all the internal fields that are related to Kafka. And here's the message itself in its Avro encoding. So you get the idea. We have our transactions over here. Unfortunately, I've got all this bump in the middle, but over here, the join's been successful and I have our payment terms here. And I think we can probably see what the problem is. All right. We have an exchange rate in the, I don't even know what the word is for that many zeros, but yeah, we have an exchange rate that's way too big. So if you were to divide any amount by that, you're going to get effectively rounded down to 0 for currency purposes. So we solved our problem. We do what we did actually at the bank, and we decided to stop trading in Zimbabwean dollar, and we can restore the service to the system. And it's these kind of investigatory and exploratory cases that indexing directly on Kafka is great for, because it's not the kind of data that you'd think would necessarily be super relevant to pass down to a downstream system. And if you have to spin that whole thing up from the back of time, downstream systems are brilliant at what they do, but if you have to spin up that backload right from the beginning of time, it's not going to be practical for every kind of support request that you want to investigate or anything like that. What you want is an easy drop-in way to query your Kafka data using SQL, and at speed. We can just be sure we're right, but trust me, we are right, by doing a really bad sanity check and finding the average exchange rate across the other currency pairs, and we're around about 2, not 9 trillion, billion, whatever. So yeah, I'm going to go ahead and say there's something wrong. But that's not all. We can let's say we don't want this to happen again. We're talking SQL here, we're talking JDBC, and we're talking your own tools that you're familiar working with. I get onto my data science guys and I hop over to my Jupyter notebook and I say, let's make sure this doesn't ever happen again. Build me a predictive model that predicts where currency pairs are going to be. Sure, same data, same connection, nice and easy. This time we're going to pull out, our needle is like currencies of USD from payment terms. There's a very small amount of data in there, so it's not really all that effective, but yeah. And you can see we have some results already. Great, that's a nice little sample. We're going to do some regression on it, and we're going to plot out, and we can see where the currency pairs are heading. I've drawn a nice little best fit through here, so while I'm doing really, really terrible business intelligence practices, I'm just going to blindly take the linear prediction, and then off we go. That's definitely 100% what euro dollar is going to be in 6 months' time. Perfect, all sorted. But you get the idea. You take your tools, you use them in the way that you like, and if you imagine me as an analyst or a guy on sport, or a guy who's been woken up at 3 o'clock in the morning and really, really wants to get back to bed, I don't care if this is Kafka data at all. I just want to munge it in the way I can normally munge everything else. And that's the kind of thing that we provide. Demo over. So, did I make it? No, I'm late. Sorry, Zion. Sorry, sure. So just a quick one. What have we got from this talk? Well, I hope I've inspired you all to embrace the change. Kafka's focus is shifting to again, and has done previously, and will do again. It's great. It's not something to be scared of. We should embrace it and use it to our best of our advantages. Kit 405 rocks. Don't throw anything away. If you have the opportunity to click on limited retention, click on limited retention. It's great. It's wonderful. Point lookups matter. It's the often forgotten case everywhere, but things go wrong. And when they do, you need to investigate. And by the way, on the flip side of that, things go right. And when you do, you need to investigate. It's really good for making strategic decisions as well. The more copies of the data, the higher the risk. Go home and play consistency bingo. It's a fun game for the whole family. And one last one that it was kind of a subtle backing to this whole talk, but Kafka is a big commitment. It changes the way you work. It changes the way you architect your entire business. Analytics on Kafka is not. It's very, very easy to have a drop-in system. It doesn't create any kind of intermediate data set, doesn't do anything like that, and gives you the analytical capability you can test, prove ROI, and then move on further. Thanks very much. Any questions that aren't about indexing theory? All good? Cheers.